lab 1, lab 4 axis pneumatic robot using PLC simulator. First procedure, we need to install the ISP software and COM-MGR software. For this software, I already installed in my laptop, this. And then just open the software, and then for the key of simulator, first we need to add file tab, this one, and just click new, and then put the project name here, just paste, and the controller type DVP, PLC type EX2, and database add the C, and then just click OK. And then we can see like this, and then at the project tree, right click, program, and create a new project. So this create new, and then it will come out like this. Like the diagram, just click OK. Then it will like this, and exit the screen, and then first create normally open contact. Okay, for normally contact, we just put here at this, and rename X0, and then for the output, just click this one and rename Y0, and after that click compile, so there is no error or warning, this one, and then click COM-MGR at the bottom, this one, open, and we need to add this, add. So for driver now, just put my DVP, and then this type is DVP simulator, and then ESX2, just click OK after that, and we need to click this and start, and then go here, and then click the online mode, wait a minute, start, restart, and click the online mode, start here. Okay, before that we need to go to the communication setting. Then my DVP. Just like this, just click OK. Okay. We start this CMT out. And click at the on now. Transport. and then start running. You can see here the PLC is running. Just pause. Okay, for exercise 1, normally open. We create a new project. Just put exercise 1. Exercise 1. Then just click OK. There at the left, program, just right click and new. Okay. And then to normally open. And then 1 for the output. The address x0, x1, and y0 for the output. So here, just put the exercise 1 and then compile. After compile, we can say 0 error warning. So go to the COM MGR and driver. Exercise 1. Types DVD simulator. Using the ES2 EX2. Just click OK. Start. And then back to the ISP soft. Go to the tool communication setting. Okay. And then just click online. Transfer. And then running. So you can see it's in running mode. So the click pause on, and if the X0 on, X1 and output does not on. So when we on the X1 as well, output will be on. Okay, that's all for exercise. Okay, for exercise 2, normally open and normally close. Okay, go to the ISP software, click new, and then just put the exercise 2, DVP EX2, just click OK. And then at the program, new, okay. Okay, so first put the normally close. Normally open and output. So here we can normally close. So this X0, X1 and Y0. So this is size 2. Then compile. So 0 error 0 1 and go to the COM MGR. Just click add. Change the driver name as size 2. Types my DVD this simulator US2. Okay, then start, go to the ISP start, conversation setting, exercise 2. Okay, and then click online, transfer the, and then run. So first one, on the right, if x1 on, output does not running. So if we off the one, x0, and then the output will run in the run mode. So to stop, just click stop the simulation. Okay. That's all for exercise 2. Okay, for exercise 3, parallel and series. So this is a series. This we parallel with this. Okay, we go to the ISP sub and then just click new. Just name exercise 3. And then the controller type DVP ES2 and just click OK. And then at the left, program, new. Okay. And then normally open, normally close. So just this, and then this one, and the output. So x1 and x3 are normally closed, so we just change normally close. So just rename x1, x2, sorry, x0, x1, x2, sorry, I think I forgot something this one. So this is normally open, this one is normally closed. So this x1, this x2, so this one by 0 for the output. So we just rename it exercise 3. So we just compile. So this one is no error. Go to the com.mgr, just add. So exercise 3 type DVP. Okay. Start. Then go to the tools, communication setting, driver exercise 3. Okay. So just make it in online mode, transfer, and then run. So it is in run mode, so we can see if we on the x1, the output still not. So the output will be on when x2 on, X0 will on, and so on. So that's for exercise 3. Okay, for exercise 4, the timer and device command. So this is the circuit. First we will do this circuit, this ladder diagram. So it's open. Exercise 4. Then let's click OK. Program, right click, new, OK. And then we will put the first one is normally open for push button. Then we will set the timer. So the timer. Sorry, TM up. Okay. Then so this one is X0 for the input, this one 0, and the timer is 100. Before that we put this is exercise. Exercise 4. And then to add the another network, just click this one. And then normally open for delay. And then one for the output. So this one is T0, well, T0 for the timer. Then this one is Y1. And then to add the command, just click. So this timer, this one is delay. Sorry, this one is push button. This delay. And then left. And one delay. Okay, just combine. Okay, so check 0 error. So go to the COM MGR, just add. So driver exercise 4 DVP simulator EX2. So this is correct. So just proceed start. Okay, then go to the ISP software, tools, communication setting, driver, exercise 4, just click OK, and then turn into the online mode. So it will transfer the code. So just running. Okay, when this one is start, it will start counting until 100. So when it reach the 100, the lamp one will be open, on. Okay, that's all for the exercise 4. Thank you. Okay, for exercise 5 counter, okay, go to the ISP software, new, and then this one is exercise 5, so just name exercise 5, DVP, EX2, just click OK. Then at the dev program, just right click, click new, and then go, that's OK. Okay, for the counter, first we will do the network one. So that we will exercise 5. Okay, first, normally open. See, this one we will set as R, and then this one is F0. This one is C0. This one. So for network 2, just click here and then normally open. X1. Then for the counter. C and T counter. So this one is 0 and 5. And then for the 3, C0 and output. Okay, then just compile. So 0 error. So go to the form MGR. So just add driver name. DVP simulator, EX2, EX2, SA2, so just click OK, and then start, and then go to the tool, communication setting, DVP driver, exercise 5, just click OK. Before that, okay, so just click OK and turn into the online mode. So transfer, and then just run. So when this one is on, so nothing happen. So we must off, and then for X1 we on. So it will start counting 1, and then we need to off and on back. So it will start counting. So we need to count it until 5. So 4, and then 5. So the output will be on. The relay will be trigger, and the while 0 output will be on. So that's all for exercise 4. Thank you.
Haniff Amdan. Now I would like to present the PLC for exercise 6 to exercise 10. Okay, this is for exercise 6, that is auxiliary relay general purpose. From the exercise, when the normally open contact at 0 is on and the normally closed contact S1 is off, M0 will be on, and latch. If S1 is on, at this time M0 contact will continue to be on because of the latch contact, and out 0 will show an action. But after running the program, if at 0 is off, the process keep running. That is for exercises. Next is exercise 7, auxiliary relay latch. From the exercise, the earliest auxiliary relay is same to the previous exercise, but for this have a special name of code. The auxiliary relay 512 is latch. Relay 512 is latch. When push button is on, the auxiliary relay is power cut. The push button is press, auxiliary relay output, and 512 is turned on. The auxiliary relay is input also connect as or gate with the start push button. That was triggered by output relay. The relay M512 turn on. The output Y0 will turn on, but when it's 0 push button is pressed, the auxiliary relay output Y0 is turned off. Like this. That's off. That's is the exercise 7. For the next is exercise 8, special auxiliary relay. For this, M1000 is to monitor the anomaly open contact. M1002 is to enable single positive pulse at the moment when run is active. M1013 is to is the clock pass for 1 second, which is 0.5 second on and 0.5 second is off, like this. That is for exercise 8. Okay, for exercise 9, this is the PLC for exercise 9. There is step ladder instruction STL and RET. For STL, it needs start and end to complete its program unless it need to be looped to start usually. We will not as start and end as RET. Each of the output will be denoted as set, and it will be symbolized as S. When each run at start, it need the output from previous run as input. For this, after run the program, this is like this. For the STL and RET for exercise 9. That's all for exercise 9. For the last exercise, that is exercise 10, that we need to build the three-way traffic light. For the condition of traffic light is green time for 30 seconds, yellow time 5 seconds, red time 3 seconds. For the SFC ladder diagram is like this is for the step of the three-way traffic light. For the step 1, all red light on for 5 seconds. Step 2, western green for 30 seconds. Step 3, western yellow for 5 seconds. Step 4, West turn red for 3 seconds. Step 5 is turn green for 30 seconds. Step 6 is turn yellow for 5 seconds. Step 7 is turn red for 3 seconds. Step 8, soft turn green for 30 seconds. Step 9, soft turn yellow for 5 seconds. Step 10, soft turn red for 3 seconds. Step 11, repeat the step 2 until step 10. And the last one is end. For the PLC diagram, this is the three-way traffic light. When we run the traffic light, this is for PLC for the traffic light. This is for initial startup. For the west green, this is for the west green. For the west yellow, this is for the west yellow. And this for the west red. For is green, is yellow, is red. Soft green, soft yellow, and soft red. And the last one is output. Okay, that's all for the exercise 10. Thank you. For the last exercise is the robot pneumatic PN test. For this is for the PLC. When the start button is on, the vertical arm will be moving down. Vertical arm moving down. After vertical arm moving down, the sensor will be detect and give the instruction to the gripper. Gripper will close the grip until the sensor will be detect, and that will be give the instruction to the vertical arm. Vertical arm will moving up until the sensor detect. After the robot will rotate clockwise or rotate anti-clockwise. After the sensor detect, the vertical arm will be moved downward until downward sensor will detect. So the grip will be open and release the object into the place. For the last is the gripper will repeat to the point A. That's all from me. Thank you.